I want to recall that when we have log base and then we have an argument equals an exponent, the base, remember, has to be positive and not equal to 1. And then we also said that the argument has to be greater than 0. So the argument must be greater than 0. The exponent can be any real number. So the exponent can be any real number. We want to find the domain. The domain is our inputs. So what can we put in for x? So we're going to take the argument. Whenever you're finding the domain, you're going to take the argument and set it greater than 0. Not equal to 0, just greater than 0. So I have 3x is greater than 0. Then you're going to solve. So you're going to solve for x, and that will be your domain. Okay. Not your domain, but the domain. So let's just write that. It becomes the domain. So 3x is greater than 0. I'm going to divide both sides by 3. X is greater than 0 is the domain. So my domain goes from 0 to infinity. So when I'm putting values into my function, I know I have to put values that are greater than 0. Let's try another one. Y equals log base 3 of x minus 5. First step is we're going to take that argument and set it greater than 0. So the argument is x minus 5, set it greater than 0, and solve. Add 5 to both sides, and we get x is greater than 5. So on our x-axis, this is our y-axis and this is our x-axis, 1, 2, 3, 4, 5, our domain would be all of the values greater than 5. So I couldn't put a 5 into the function, but I could put anything greater than 5 into the function. So that means the domain would be 5 to infinity. I'm going to erase this y-axis because it's really not necessary. We're talking about just the x-axis. That's our domain. So your domain is the x-axis. And anything greater than 5 is allowed. So we box it. And when we graph, we know that we start putting in values greater than 5 into our function to start creating a table of values to graph from. Okay, y equals the natural log of x squared. Y equals the natural log of x squared. So my first step is to take the argument, which is x squared, and set it greater than 0. Now, when will x squared be greater than 0? Well, if I put any negative number in, I'm going to get greater than 0. Because a negative times a negative is a positive. All positive numbers are greater than 0. If I put a positive number in for x, that's going to be greater than 0 because any positive times itself is positive, and all positive numbers are greater than 0. But there's one number that won't work. X cannot equal 0 because 0 times itself is not greater than 0. It's equal to 0. Therefore, on a number line, I would have all my negative values, all my positive values, but the value that's not allowed is 0. So the domain would be negative infinity to 0 and 0 to infinity. And that would all be with parentheses so that 0 is not included. We can also think of x squared as being the beautiful graph that it is. It's a parent function, right? And when will this graph give me outputs? What values of x give me outputs, right? So what outputs are going to be greater than 0? Well, what do I put in for x? If I put in any of these negative numbers, I get positive values out. Positive, 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 positive. But if I put a 0 in, I don't get a positive out, I get a 0 out. But then once I hop over 0, I start getting positive values out again. So negative infinity to 0, and then 0 to infinity. So that's another way to look at it too, is graphically. I found that graphically is really helpful. So let's kind of think about that again with this one. Let's think about this graphically. So I've got my argument is x squared minus 49. And the domain is all about the argument. The domain is all about keeping the argument greater than 0, which is positive, keeping the argument positive. So we've got x squared minus 49 is greater than 0. Now remember when we solved these inequalities with quadratics, we factored and we found our critical values. Our critical values are -7 and +7. If I put a -7 in, I'm going to get -7 plus 7 is 0. Anything times 0 is 0, and 0 is not greater than 0. So when I put a -7 in, I don't get an output that's greater than 0. And the same happens when I put in +7. So those two values are not going to make the inequality true. If I put a -7 into my argument, I'm going to end up with 49 minus 49, and the argument can't be 0. It has to be positive. Now, if I put in a value in between -7 and 7, maybe a 0, will that work? If I put in maybe a -10, will that work? If I put a +10 in, will that work? We need to try each section. Does the green section work? Does the blue section work? Does the purple section work? So we need to try all of these sections. Which ones work? Well, if I put a -10 in, -10 plus 7 is a negative number. -10 minus 7 is a negative number. A negative times a negative is a positive, and positive numbers are greater than 0. So this section, this green section, is true. Any value in the green section will make the inequality true. Then I'm going to put a 0 in. If I put a 0 in, 0 plus 7 is positive. If I put a 0 in, 0 minus 7 is negative. A positive times a negative is a negative, and negative numbers are not greater than 0. So this section does not work. It creates false inequalities. And then if I try, let's find a purple color here. I've got purple around here somewhere. We don't. We must add purple. We must add purple. There's a good purple. That's a good purple. Oh, that's a better purple. We want it to be nice. That's kind of more blue than purple. There we go. We'll just add that. If it doesn't work, we could always change it later. So I'm going to come over here, purple. So when I put a +10 in, 10 plus 7 is positive. 10 minus 7 is positive. A positive times a positive is a positive, and positive numbers are greater than 0 every time. So our domain is -infinity to -7 with a parenthesis because -7 does not work. The middle blue section does not work, but we pick up again at 7 to infinity. Now graphically, here's another way to look at this. It's important that you can see this graphically because it might just help you do this easier. So we've got intercepts at -7 and +7. Those are our critical values. And we know that x squared minus 49 is a parabola that opens up. And we want positive outputs. We want values that are going to give us positives. Well, anything from -infinity to -7 is going to give us positive outputs. So -infinity to -7 works. But when I put a -7 in, I get a 0 out, and zeros are not allowed to be the argument. Now, anything in between -7 to 7. So anything in between -7 to 7 doesn't work because I get negative outputs. And negative numbers, these are all negatives, negative numbers are not greater than 0. But then we come over here and we've got, picking up over here to the right of 7, we've got positive outputs again. So that gives us our 7 to infinity, which is what we've written here, and it works. Now this is the real question. Can you find the domain of this problem? Can you find the domain of this problem? Go ahead and try, and when you come back, I'm really just giving you the answer, so please make sure you press pause if you don't want to reveal the answer. Okay, welcome back. Hopefully you're ready to reveal the answer after some hard work, and you should have gotten the domain as -infinity to -2 and +1 to infinity. Now some people will write that -infinity to -2 union with 1 to infinity, and either one of those is correct. I tend to use the comma. I tend to use this comma in between my two intervals, but it's completely a personal preference. Okay, now that we're comfortable with our domain, now that we're comfortable knowing what values we can put into our function, we're going to start graphing them. We're going to start graphing them, and we're going to discuss their relationship, the relationship of the logarithmic function to the